Hello everyone, I hope you all are doing well. This side Priya Bhatia, and in this specific video we will try to talk about now that how with the help of Sklearn we can import Adaboost and directly implement the steps that we have covered up in our previous video. See, the main objective to showcase you everything step by step is to enhance your knowledge in terms of how internally the algorithms are working. So that if someone will ask you, you should not say that it's a black box thing, right? You should be aware about the mathematical intuition about every algorithm that we have, so that in future, if you want to explore the research area towards ML also, you can easily able to explore that. Because always remember, in research per se also, when you want to build some new algorithms out of these state of the art models that we have, you need mathematics. And if you will try to study from the beginner level itself, and if you refer one standard book alongside, it will be of great help, right? So in this video, in this section of the video, we will cover up how with the help of Sklearn we can implement Adaboost, and we will do the hyperparameter tuning for the same. So without wasting any time, now let's get started, and we'll try to see that how practically in a real-time implementations with the help of Sklearn package we can implement Adaboost. So now let's try to focus on that how with the help of this Adaboost classifier directly we will be able to implement any of the project. If you remember in the previous discussion, we have seen the step-by-step implementation in the Adaboost implementation file, right? I hope you all remember that. Now, usually you won't follow the step-by-step implementation. It is just for showcasing you that how the internal maths is working in Adaboost. But how this implementation whenever you are doing real-time projects will be done, this is directly by extracting the Adaboost classifier. So I'll just showcase you today that how this things will be done. So what will happen is we are directly taking up, let me recorrect the file. We are importing all the required frameworks at the very first instant. So you will see that I am importing all the required, you can say, frameworks. Once it is done, right? Once it is done, you will be able to see that we are fixing the CDES42. Why? Because I don't want that at every point of time we will be able to get different samples. This thing you can do in the previous implementation also, because if you remember in our previous implementation, I showed you that at every iteration we're getting something different samples, right? In the second DF and third DF. We can fix that by making a seed, and then we are just taking, creating our own data samples here, right? Let me just create that. And if I'll just try to showcase you now, here you can see that how the plot looks like in the scatter plot. What I want is, I want to apply the Adaboost classifier, which is basically helping me to classify the yellow points and that you can say dark points, violet points that we have. So we want to somehow get a classifier which will be easily able to distinguish between these 2 points that we have, right? So what we will do now is we will directly call our sklearn.ensemble, and inside that, because it's a part of ensemble technique, inside that we're calling Adaboost classifier. Apart from this, in the model underscore selection part, we're using cross validation score. I'll talk about this cross validation in the upcoming module in a lot more detail. So don't worry if you don't able to understand that how actually internally this cross validation works, right? So here we are trying to create our model by the name of Adaboost classifier, and we will call this specific model on top of our dataset that we have X and Y. Scoring we are doing as an accuracy, and let's try to run this code. And now what we will do is we will see that this is something which we are getting as a result, which is 78.6, right? What we can do is we can fit our data, and you can see the decision boundary that how it looks like actually. So here our model name is model. So we will just use this model to check it out that how our boundary looks like. Here you can see that there is still a lot of scope where yellow points are there. My model is not able to properly classify. And for that, what we can do is we can tune our hyperparameters available in Adaboost. Now, let's try to focus on that part of Adaboost parameters. There are very limited parameters that we have in this Adaboost classifier, right? That's a good thing. One parameter which you can see is an estimator, which usually when we are doing any real-time project, we will not touch upon this. It is by default decision tree classifier. If let's say you want that I want to use maybe logistic regression for a classification purpose, or I want to use some other model altogether, you can use that, okay? There is not an issue. It's just that the model will remain the same in all the iterations. That's the thing which I think when I started the boosting technique, I have already talked about. So you can see here the base estimator from which the boosted ensemble is built, or you can say in other words, weak classifiers are built. Here you can see that this is initialized with max depth as equals to 1. We have already seen in our step-by-step implementation the same thing. By default, you will see in maximum projects, people usually go for decision tree classifier itself because it gives a better result. Next is the number of estimators. It indicates that how many number of iterations you want to explore. For example, in our previous discussion, we just have done 3 iterations. We have curated a second DF and third DF. But by default, it is 50. But we can change this like at what point of time, in depending upon what data you are dealing with, that number of estimators will get changed, and you can fit that particular estimator value, right? These values in the range from 1, minimum will be 1, till infinite. You can see here. After that, learning rate. This is something which is very, very important to understand. This learning rate is a parameter which is basically contributing to the overfitting problem in a given model, which is Adaboost model. Usually what happened is that, for example, we will be having, if you remember, let me just open a new file altogether, right? So that we can just discuss regarding this specific point in a detail. So if you remember, we have a parameter of alpha in this boosting classifier, right? We have discussed that. In Adaboost, we have a parameter of alpha, which is nothing but 1/2 natural log of 1 minus error upon error. And usually this learning rate, which is eta, is multiplied with this alpha itself. This is something which I am calling it as a learning rate. And this is by default 1. That is why I have not used it in my previous discussions while I was talking about the mathematical intuition. And you know that this alpha is basically responsible to update the weights, right? To update the weights. How? We have seen that wherever there is a misclassification, there are 2 things that we have. Wherever there is a correctly classification, we are multiplying our values with the original weight that we have into e to the power of negative of alpha, not negative, it's negative of alpha. And wherever there is an appropriate misclassification is being done, means vice versa case, wherever there is a misclassification of data points, what we are observing is it will be the original weight that we will be having multiplied with e to the power alpha, right? This is something that we are getting here. So this is the main scenario via which we are updating the weights altogether of correctly classified and misclassified data points that we have, right? In this specific case, when you are multiplying this value of alpha with eta, what is happening with the learning rate? Usually, in order to avoid the overfitting, we are taking this value of alpha learning rate as low, let's say 0.1. So what will happen? As and when you will take the value of eta as 0.1, it means that you're trying to reduce this value of alpha by 10th quantity, right? 1/10. So somehow you are trying to do a shrinkage of the alpha value. And with this shrinkage, what will happen is there will not be a abrupt change in the weights. Somehow you will be able to shrink the weight update values as well, right? This will basically help my model at any point of time to reduce the overfitting. So that is where this learning rate came into picture. There is one very good article which you can refer in this part. You can see decreasing the learning rate makes the coefficient of alpha smaller, which reduces the amplitude of that weight update, which we have seen. This translates into smaller variance, and therefore it will fewer differences between the weaker classified decision boundaries. So at every point of time, it will make a very minor change, you can say. If the value is increasing, then vice versa will happen. And here you can see that basically the idea is to slow down the learning if we will be using a learning rate parameter, basically it will try to allow to dramatically reduce the overfitting. That's the main core idea of this alpha parameter. Apart from this, learning rate parameter, I hope it is clear to everyone now. We have an algorithm. There are two algorithms working internally. Either it is SAMI or it is SAMI.R. By default, it is SAMI.R, which typically converges faster than SAMI. It's a better optimizer as comparable to SAMI algorithm that we have. At the end, we have random state. If you want, you can fix it so that at every point of time, you will be able to get the similar number of samples, right? So what you can do is you can just try to see if, let's say, you will pick up very big number of estimators. At that point of time, you can just, if you will just try to remove this parameter of learning rate, and you have, let's say, this as the model underscore 1, and you will try to fit this model and you will try to see the results. Now you have increased the number of estimators, right? So what is happening is, let me just try to curate a decision boundary of model underscore 1. One thing which you will be able to observe, in the above scenario, we have taken the default parameters, right? We have not used any parameter as such on our own. So it's a default one where the number of estimators was 50. But now if you have changed to 1500, you can see somehow overfitting starts, right? Can you see that small data points also it is trying to capture, right? The overfitting problem is coming up. If you will just try to use the same code, but now what you can do is you can try to take a parameter of learning rate and maybe you can try to fit this value at, let's say, 0.1. Maybe you will be able to see a small change that there will be a better scenario as comparable to above scenario. Your model starts smoothing better. You can see that overfitting will be lesser. So you have to somehow, balance these parameters so that you will be able to get a best model out of it. After that, in order to, you can say, optimize the parameters, you can say in Adaboost classifier, as we have discussed in the past also, that grid search CV is a good idea, which will provide you a better results. So you can create a dictionary where you can pass the number of estimators that might be 100 is a good idea, or 500 is a good idea, or 10 is a good idea, or 50 is a good idea. Similarly, you can just verify that what could be the best learning rate which we can pick up. You can check the algorithm for the convergence per se, and whatever be the grid search CV parameters you're getting as a best parameter, you can use that. Initially, when I run this file, this is what I'm getting as a result. I'm not running it again because it will take some time to get the results. So I'm just showcasing you at your end. I will share this file with you. You can try that in the grid search CV. What are the best parameters you're getting? Even you can try to apply the similar approach on a CSV based file, real-time data, and you can check the best parameters, and depending upon those specific parameters, you can just rerun your algorithm by applying this Adaboost classifier with those specific parameters, right? And there will be a better chance, higher chance that you will be able to get a better accuracy in terms of the results part. So this is the overall idea behind this Adaboost via Sklearn implementation. I hope it is clear to everyone. Previous implementation was to understand the mathematical part, right? Just to showcase you that whatever maths we have covered up, how we can implement that. This specific portion is just to showcase you that in real-time projects, how will you apply the Adaboost classifier, right? Both of them are really important to understand. Apart from this, you can refer the standard book of Hands-on with Machine Learning to understand more about this particular boosting algorithm that we have covered up, right? I hope that these sessions are quite, understandable. And if you still have any issues, any doubts, please try to reach out to me and please resolve your doubts as soon as possible. So now I hope that you will be able to get an appropriate understanding end-to-end about Adaboost algorithm. In the upcoming part of the section, we will start our new journey in the boosting algorithm, I would say, where we will start the next important algorithm that we have, which is gradient boosting, sorry. You will observe that in that specific algorithm also, we will follow the same approach. First of all, we will talk about mathematical intuition, followed by the implementation for the same. So stay tuned. I will see you all in the upcoming videos.